All you homeowners have unique needs. Some feel the need to paint their door a vibrant shade of blue. Others have the need to decorate their bathroom with fish, anchors, and other nautical items. And because each homeowner has unique needs, Geico helps you get the right coverage for your home and what's in it. That way, you get exactly what's right for you, even if your needs are unique. Get more with Geico.
This is SpaceTime Series 28, Episode 39, for broadcast on the 31st of March 2025. Coming up on SpaceTime, determining the date of the Moon's oldest and largest impact crater, NASA's Punch mission safely in orbit, and the countdown's underway for mainland Europe's first orbital rocket launch. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have finally put a date, and consequently an age, on the Moon's oldest and largest impact crater. The new findings, reported in the journal National Science Review, suggested the giant lunar South Pole Aitken Basin was created by a massive asteroid impact some 4.25 billion years ago. The new findings are based on lunar regolith collected by China's Chang'e 6 sample return mission, which visited the Moon's far side last year. Astronomers have long sought to determine the age of the ancient Aitken Basin, the largest and oldest known impact structure on the lunar surface. The basin is a vast impact structure spanning the Moon's South Pole far side. It's roughly 2,500 kilometres wide and up to 8.2 kilometres deep, making it one of the largest impact structures in our solar system. It's believed to have been formed during a period of intense asteroid bombardment that shaped much of the solar system within its first few 100 million years. Despite its significance, the exact age of the basin has remained elusive, hindering efforts by astronomers to understand its role in lunar and planetary history. Previous estimates of the basin's age have varied widely, highlighting the need for direct analysis based on actual geological samples. The Chang'e 6 mission's return of lunar samples from the basin has allowed a scientific research team led by Chen Yi from the Chinese Academy of Sciences to be given an opportunity to resolve this mystery. They focused on impact melt rocks within the samples, which provide crucial clues about the basin's formation. Chen says the collision generated a massive sheet of impact melt. To accurately determine the basin's age, the authors first needed to identify the products of this melt within the Chang'e 6 samples. So Chen and colleagues meticulously analysed some 1,600 fragments from 2 source samples, identifying 20 norite clasts with textures, mineralogy and geochemical signatures that were consistent with an impact origin. Using a lead-lead dating system for zirconium-bearing minerals within these clasts, they uncovered evidence of 2 distinct impact events, dated at 3.87 billion and, more importantly, 4.25 billion years ago. The older noritites, dated at 4.25 billion years, exhibited structural and compositional features suggesting that they crystallized at various depths within a common impact melt sheet produced by the Aitken Basin forming event. So, the studies provided the first direct sample-based evidence that the Moon's largest impact basin was formed just 320 million years after the actual birth of our solar system. Consequently, it serves as a critical anchor point for refining lunar cratering chronology and reconstructing the timeline of the Moon's early evolution. This is SpaceTime. Still to come, NASA's Punch mission safely in orbit, and the countdown underway for mainland Europe's first orbital rocket launch. All that and more still to come on SpaceTime. Now safely in orbit, NASA's Polarimeter to unify the Corona and Heliosphere, or Punch constellation, is now undergoing a 90-day commissioning period, undertaking a series of in-flight checkouts prior to commencing its 2-year mission. The 4 spacecraft will make global three-dimensional observations of the Sun's upper atmosphere, the Corona. This will allow astronomers to better understand how it transforms into the constant stream of charged particles known as the solar wind, which bathes the Earth and the rest of our solar system. A key part of PUNCH is the United States Naval Research Laboratory's Narrow Field Imager, a compact, externally occulted chronograph. It blocks direct sunlight from entering the main optical aperture, which views the corona and star field around the Sun using a compound lens system. By imaging the transition of the corona into the solar wind, astronomers will better understand exactly how the Sun generates the space plasma environment. And that will help scientists make better predictions about space weather events like solar flares and coronal mass ejections, which can fling powerful geomagnetic storms towards the Earth. It's these solar storms which trigger the spectacular northern and southern lights, the aurora borealis and aurora australis. But they can also damage and even destroy spacecraft by shorting out delicate electronics or by causing the Earth's atmosphere to wobble and expand like jello. That increases atmospheric drag on satellites, resulting in orbital decay and the need to use up more fuel in order to maintain operational altitude. These geomagnetic storms also interfere with communications and navigation systems, and they can overload terrestrial electricity transmission grids on the ground, causing blackouts over wide areas. They also increase radiation exposure for crews operating in space, and even for people on high-altitude aircraft. So, this narrow-field imager aboard PUNCH marks a significant step forward in science's ability to understand the dynamic processes that drive space weather events. By imaging the transition of the Sun's atmosphere into the solar wind, they can gain crucial insights that will ultimately improve their ability to predict and mitigate the impacts of these powerful events, especially now as the Sun reaches solar max, the climax of its 11-year solar cycle, a time when the star is especially violent. In fact, just over the past week, another geomagnetic storm hit the Earth, and a massive coronal hole has opened up in the Sun's atmosphere, sending even more streams of charged particles towards Earth. NOAA, America's National Oceanographic and Atmospheric Administration, issued a G2 geomagnetic storm warning for the event. Just like tropical cyclones, geomagnetic storms follow a 5-point severity scale. It's a logarithmic scale, with G2 class storms considered moderate in strength. But they could cause minor technological disruptions such as radio blackouts, GPS malfunctions, and an increased chance of aurora at lower latitudes, and those are exactly what has happened. G2 strength geomagnetic storms hit planet Earth on around 360 days over each 11-year solar cycle. And the Space Weather Prediction Center issued an extended storm warning because of the detection of this coronal hole facing the Earth. Coronal holes are cooler, darker regions of the corona that are less dense than normal, allowing high-speed charged particles to gush outwards into space. And currently, one of these escaped high-speed streams is pointing directly at the Earth. Astronomers now think the Sun reached solar max in October last year. That's because since then there's been some evidence of polarity reversal in magnetic filaments extending out from sunspots. It's a process that will continue for several more months as the Sun's magnetic poles continue to flip. And just to further underline the point, a massive 1.1 class solar flare and simultaneous coronal mass ejection erupted out of the Sun's southeastern quadrant on Saturday, sending a gigantic blast of plasma and solar particles deep into space. In fact, the event's been described by SpaceWeather.com as one of the most beautiful and significant eruptions in recent memory. But the website also points out that Earth dodged an extreme geomagnetic storm. Nevertheless, a strong R3 radio blackout centered on the Caribbean did develop from the blast. If the eruption had been directed directly towards the Earth, a Carrington-level geomagnetic storm could well have developed within 30 hours. Luckily, the explosion was directed towards Jupiter. But the sunspots which triggered the blast remain active and are now rotating towards facing the Earth in the next week or so. Ultimately, if this magnetic filament channel refills again over the next week, it's possible that we could see a big solar storm launched, and this time crossing through the Earth's strike zone region. To put it simply, if all the power from this one eruption could be harnessed, it would probably power our entire planet for over 100 billion years, far exceeding the remaining lifespan of the Sun. Predicting the impact of space weather, from minor fluctuations to major coronal mass ejections, requires a comprehensive understanding of the solar wind. And while originating at the Sun, these events nevertheless evolved significantly during their journey towards the Earth, especially within the sparsely imaged region between the solar corona and the inner heliosphere, posing a significant scientific challenge. By capturing the evolution of coronal mass ejections and solar flares, PUNCH will provide scientists with new data on their formation and propagation. This report from NASA TV.
PUNCH is an acronym. It stands for Polarimeter to unify the corona and heliosphere.
The corona is the outer atmosphere of the sun. It's the part that is no longer gravitationally bound to the sun, and it has so much energy that it flows outwards, filling our solar system, and pushes against the interstellar medium, making a bubble, and that is the heliosphere. And this system of how the corona turns into the heliosphere is what PUNCH is trying to study.
So PUNCH is fundamentally 4 cameras that work together to make composite movies. We have a narrow field imager that views the space close to the sun, and then we have 3 separate wide field imagers, each of which has a large squarish field of view that looks way off to the side, out to 45 degrees away from the sun. That allows us to do something that no other mission has been able to do, which is routinely track coronal mass ejections, space storms, all the way across the solar system as they approach the Earth.
By better understanding these storms and better understanding how they propagate on their way to the Earth, we'll be able to inform our partners on how to better forecast these events in the future. And that's really important for protecting our astronauts, our satellites, and our power grids.
Once we start producing images, you'll be able to look at PUNCH data directly and see the kind of science we're engaged in. You'll be able to see things that are present in the sky right now, and you're not aware of them because they're washed out by the brightness of the sky itself.
We are poised to do tremendous science with PUNCH because it provides this global context of what is happening in the corona and what is happening throughout the inner solar system so that we can connect the details to the bigger picture.
You might say that PUNCH is the next chapter in the study of heliophysics as we bring imaging and cross-scale understanding out so that we can develop a coherent understanding of the entire system that starts at the corona and extends out to envelop the planets themselves.
And in that report from NASA TV, we heard from PUNCH mission scientist Nicolene Villol from NASA, as well as PUNCH principal investigator Craig DeForest from the Southwest Research Institute in San Antonio, Texas. This is SpaceTime. Still to come, the countdown underway for the first orbital rocket launch from mainland Europe. And later in the science report, a new study warns that microplastics are now affecting the ability of plants to carry out photosynthesis. All that and more still to come on SpaceTime. High winds and bad weather has forced mission managers to scrub what should have been the first ever orbital rocket launch from mainland Europe. The launch by Munich-based ISA Aerospace involves its new Spectrum rocket, which will launch from Norway's Andøya spaceport on the Arctic Circle. The test flight is seen as a key step in the new European space economy. Until now, all European orbital rockets have been launched from the European Space Agency's Kourou spaceport in French Guiana. And until recently, there have been ongoing delays in the development of the new Ariane 6 heavy-lift rocket, and the Vega C light launcher had been suspended from flight following an upper stage component failure. While both now have flight status, the delays have been long and costly. Compounding the problem is the fact that Europe also lacked access to Russian spaceports and launches since 2022, following the West's embargo of Moscow in relation to the Kremlin's invasion of Ukraine. ISA Aerospace's new 28-metre tall two-stage Spectrum rocket is designed to carry payloads of around 1,000 kilograms into low Earth orbit and 700 kilograms into sun-synchronous orbits. Its first stage is powered by 9 Aquila propane and liquid oxygen rocket engines. Spectrum's upper stage is equipped with a single Aquila propane and liquid oxygen engine designed for multiple ignitions, thereby allowing it to be shut down and reignited on numerous occasions as needed, eliminating the need for an additional kick stage. Spectrum will become the first privately financed European launch system to reach orbit. Of course, Britain's Richard Branson and his Virgin Orbit have done it from the United States, using air-launched rockets fired from a modified Boeing 747 airliner that had taken off from a conventional runway. but they appear to have shut down operations following a failed 2023 attempt to air-launch a rocket from the 747, which had taken off earlier from Cornwall. Norway's Andøya and Svalbard rocket ranges, together with the Estrange spaceport in neighbouring Sweden, have already undertaken over 1,000 suborbital launches, flying sounding rockets on primarily scientific missions. And this new launch is being seen as an extension of those capabilities. This is SpaceTime. And in a late update to that story, Spectrum finally launched late yesterday. However, shortly after liftoff, it began veering off course during its planned rollover manoeuvre 18 seconds into the flight, resulting in a catastrophic failure. We'll have a full report in next week's show. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that microplastics are now affecting the ability of plants to carry out photosynthesis. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, PNAS, demonstrates the critical threat these pollutants cause to Earth's primary production and food security. Microplastics are defined as plastic debris smaller than 5 millimeters. It's now found to be contaminating environments from deep-sea sediments up to tall mountain glaciers. The study's authors evaluated the relationship between microplastic exposure and photosynthesis across terrestrial, marine and freshwater ecosystems. Despite the growing awareness of this hazard, the effects of microplastics on photosynthesis in the ecosystem have remained unclear until now. By analysing 3,286 records using metadata analysis and machine learning techniques, the authors have shown that microplastics have decreased photosynthetic efficiency by 7.05 to 12.12% across terrestrial plants, marine algae and freshwater algae. These reductions translate to estimate annual global losses of between 4.11 and 13.52% for key staple crops such as rice, wheat and maize. In aquatic ecosystems, microplastic-induced photosynthesis inhibition is projected to cause net primary productivity losses of between 0.31 and 7.24% annually. A new study has found that ditching butter in your diet and replacing it with plant-based oils could help protect you from cancer and heart disease. A report in the Journal of the American Medical Association looked into the diets of over 220,000 people, finding that those who ate a larger amount of butter were far more likely to die of cancer compared to those who consumed little or none. They also found that people who consumed higher levels of safflower, soybean, corn, canola and olive oils were less likely to die from cancer or heart disease. Now, while this kind of study can't prove that butter directly affects your chances of survival, the authors say the study adds to a growing body of evidence that you really should be swapping out animal fats for plant-based ones. That's if you want to live a longer, healthier life. Sharks have been recorded actively producing sounds for the first time. The findings, reported in the Journal of the Royal Society Open Science, involved recordings of New Zealand rig sharks, which showed that they were deliberately making short, sharp clicks when they were handled underwater. The authors suggest that based on the click's acoustic characteristics, they're being created by the sharks by forcibly snapping their flattened teeth together. They believe the sharks are doing this in response to a disturbance or distress. But further research is needed to determine other uses and their biological significance. Well, Transport for London have been kept busy. They've been asked to search their records for sightings of ghosts, spirits, ghouls, poltergeists and banshees on the London Underground. And as Tim Mendham from Australian Skeptics explains, despite an intensive search, they found only one single solitary case.
This is a very interesting story, actually. It starts off being so totally trivial, but it actually becomes implications. Someone put in a Freedom of Information request to the people who run the London Underground, which is Transport for London. And what they wanted to know was if there was any evidence of the paranormal that was sort of in their record. So the Transport for London thought that was interesting. They'd probably never been asked that question before. So they did a word search into all the reports they had. And what the words they searched for were ghost spirits, ghouls, poltergeists and banshees, which is what the people were asking for. They're only looking for information for about the last 2 or so years. So they weren't going back to the 1800s. That might be a bit hard to search anyway, those documents, but never mind. Transport for London came back to them and said, yep, we've done this word search and this is what it is. And what we found was that there was so many references to spirits and ghosts, and the only one that actually wasn't saying, I'm in good spirits, or I'm intoxicated by drinking spirits, was a 15-year-old boy who was distressed, possibly lost in King's Cross Station in December 2023, who mentioned that he had seen ghosts. Now, this search or this request was partially inspired by someone trying to find out if there's any activity near Aldgate East Station, because Aldgate East Station is where Jack the Ripper, not the station itself, but the area is where Jack the Ripper had his way back in the late 1800s. Yes, so he killed at least 5 people, possibly more. But anyway, they wanted to see if therefore the ghosts of these people were haunting the underground stations or the railways generally. I don't know why. Surely there are other areas, other buildings around that they could have haunted. Why just the undergrounds? I don't know. Maybe they're wide-ranging ghosts. Who knows?
Maybe they're gunzels.
They're what?
Gunzels. You've never heard the term gunzel?
I've never heard the term gunzel.
The term actually comes from the Maltese Falcon movie starring Humphrey Bogart.
Directed by John Huston.
Yes, in that movie, a gunzel was a young thug carrying a gun. He was named
He's a Weasley-looking guy, Wilma.
In the film, a gunzel is a young thug carrying a gun, but in Australian rail enthusiast terms, a gunzel is someone who is basically what Brits call an anorak, who hangs around the end of platforms photographing trains.
Train spotter.
Train spotter, carrying a camera insteed of a gun.
Yes.
So, yeah, that's a gunzel.
I'm used to saying someone who was a bus spotter. Ordinary
they're a
government
branch
bosses.
of gunzel, I think.
I know. He'd photographed the front of the bus with the route number. Anyway, back to Aldgate. So, reason for this study was to try and find if there were examples of ghosts, etc., that had been reported, poltergeists of any sort, whatever. And the only thing they came up with was this 15-year-old boy. And I'm sure the Transport for London sort of issued this report a little bit tongue-in-cheek, because they were the ones who mentioned that when they said the spirit was, half the time it was about alcohol spirit, and that someone was intoxicated on the train or whatever, hopefully not the drivers. But anyway, so there was just one reference to a 15-year-old boy. That was suddenly picked up everywhere by the saying that the Transport for London had found an example of the paranormal on its underground, and this 15-year-old boy suddenly became famous. Yeah, but the case is famous. Even though it was issued as a tongue-in-cheek report, there was never any actual proof of a ghost that this kid saw. He was distressed.
That's really surprising, isn't it? You think there'd be more, considering London's got, 10, 12 million people who use the tube and the underground on a regular basis every day?
Well, some of these tube lines, of course, also ran through plague pits and cemeteries. So they actually had to remove bodies to put the tube lines through.
Well, they had to do that at Central in Sydney as well.
Yeah, I mean, the plague pits everywhere, apparently. And it's not a nice thing to remove a plague pit, because if you're talking about bubonic plague or something, it's quite fascinating that a non-story becomes a story. Hey, what's new in the world of reporting?
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.